Hey everyone, it's Mr. Voikin here, and as I told you at the end of the last video, we will now, in the second video, take a look at the parallel LED resistor circuit. So on the screen to the left in Tinkercad, you can see that that first circuit that we built is right there. And over to the right is the schematic diagram again. So let's take a look at these components and what is similar from before. Well, we still got ground on the bottom and 12 volts up top. Now, if we were to follow this, the ground actually goes up and it goes over all the way to there. So that would be what's representing the ground rail, and the V plus would come down to here and then slide all the way over to the end there. And you can see that we've got these components right here, R2, R3, and R4, which are connected down to ground at those points right there. And up top, we've got LED 4, LED 5, and LED 6, which are connected up to the positive rail at those points right there. So let's make those connections on our virtual breadboard. So we'll go back into the parts. We'll bring over another breadboard. And we're going to go grab a red wire and make those connections again. So you can see that red needs a jumper wire right there. It's going to need a jumper wire right there. It's going to connect the bottom to the top. We're going to need a black jumper wire going from here to there, and here to there, and one from there to there. And again, for some reason this one decided it wanted to go black, but we're going to switch that back to red and sort of zoom in here so we can see a little bit better. So the breadboard is set up. We don't have our power connected yet, so I'm going to do that. I'll just slide the breadboard over right there and go find that 9-volt battery. Now I know in the schematic diagram it says 12 volts, but I can't see how to change this to 12 volts right now without hooking up a bunch of batteries in series or something. But for this demonstration on how to make all the connections, this will be good enough. And in class, when you do the actual lab, you can connect the circuit to 12 volts. So I'll grab my red wire, connect to the positive, which is right here, and head up to the top rail and slide over. That is done. I'll switch that to a black wire and head down to the bottom rail and make that connection. Straighten that out and straighten that out. Looks beautiful. And we'll zoom in and just slide it over a little bit right there. And let's grab the parts and build this. So as you can see in the schematic on the left hand side, we've got a 6R2 resistor connected down to ground, R2. I've got R3, a 6K8 resistor connected down to ground, and R4, a 6M8 resistor connected down to ground. So every one of those is connected down to that ground point. So to do that, we just need to go grab a resistor and we'll pop it down to ground. Now we can just go Command C and Command V and put another one in there, and Command V and put another one in there. Now those are, all three of these are 1K resistors, so we're going to change those so they have the same value. So instead of 6R8, we're going to write 6.8, and that will just be ohms. The second resistor is also a 6.8 but it is kilo ohms right there. And the third resistor is a 6.8, and it will be mega ohms right there. Okay, so we've got our 3 resistors on the board connected down to ground exactly as displayed in the schematic diagram. Now, the R2 is connected up to the negative leg of LED 4, and R3 is connected to the negative leg on the LED of LED 5, and the R4 is connected up to the negative leg of LED 6. So I will go grab 3 LEDs out of here and connect the negative legs to those resistors. So there's the LED, and we'll go 1 again, Command C and V, 2 and 3. The first one is red, the second one is orange, and the third one is green. Okay, now we see over in our schematic the only connections left to complete is from the positive legs of those LEDs up to the positive rail right there. So we will do that using a jumper wire, and we'll stick with blue, and this, oh no we won't, because we're going to the positive rail we're going to use a red one. So that goes up here to the positive rail, and I can just straighten that out, make it look all pretty. And this one goes up to the positive rail as well. And the last connection also going up to the positive rail. And we're finished. Okay, so we have the power connected. We've got all of our jumper wires in, and we've made the connections between our LEDs and our resistors as indicated on the schematic diagram. So all that is left to do is press Start Simulation, and hopefully those LEDs will light up. Oh no. Okay, well, what's happening here? Well, we can see that there is an explosion on the red LED. And why is that? Well, 6R8 is way too low of resistance to slow the current down enough. So essentially there's too much resistance going through that red LED, and boom, we have killed that red LED. Now, if we look at the orange and green ones between the top schematic and this, or sorry, the breadboard up top and the breadboard on the bottom, you can notice that they are not on, or if they are, the orange one might be on, but just so very little current is going through it that it doesn't really light it up very much. And the green one having 6.8 mega ohms of resistance, that is just way too strong of a force stopping the current from coming through. So essentially the green LED will not light up at all. So those 3 resistors on those 3 LEDs were all of the incorrect value, and if you wanted to put the correct values in, we would just have to use Ohm's law again and calculate each of those resistor values for each one of those circuits, because there are 3 circuits there. So if you look over at the schematic drawing, we've got this parallel line, the second parallel line, and the third parallel line. Now with all of those, the voltage supply is going to be the same. It's going to be 12 volts. But the voltage drop is going to be different. So for the circuit number 1, I would use a 1.8 volt voltage drop. For circuit 2, I would use a 2.0 volt, and for circuit number 3, I would use a 3.5 volt drop. So for number 1, it would be 12 volts minus 1.8 volts and divided by 0.03 amps. For the second one, it would be 12 volts minus minus 2.0 volts divided by 0.03 amps. And I will just move this up right here so I can complete the third one, which would be 12 volts minus 3.5 volts divided by 0.03 amps. And if you punch that into the calculator, you will get your resistor values, the proper ones that should be used for that circuit, and done. Now, after watching the first video and this video, you should have enough to be able to assemble both of these circuits in class. And then when you're done, we'll move on to the third circuit, which is adding in switches and diodes so that we can control the circuit a little bit better.